So we just finished chord and angle form of a circle. The fifth one that we are going to discuss is the parametric form of a circle. Parametric form of a circle, that is equation of circle in parametric form. So we'll take the simplest case first. Suppose there is a circle whose center is origin and radius is r. We know that we can write this circle as x square plus y square equal to r square, which is the Cartesian form. So this equation contains xy, which are Cartesian coordinates. So it is called Cartesian form, Cartesian equation or Cartesian form. Now, what is this parametric form? So if suppose OP makes an angle theta with axis, we just drop a perpendicular. Clearly, we know that from this diagram, cos theta is equal to x by r, because when the point is xy, this is x and this is y. So cos theta is x by r, sin theta is y by r. But if you carefully observe, when I square and add these two, I'll get back this equation. So whether I write this single equation or these two separately, it is one and the same. So this type of representation, x equal to r cos theta, y equal to r sin theta, will work for any point on the circle. Only thing is, for different points, like if the point is here, the angle is 0. If the point is here, the angle is 90. If the point is here, angle is 180, etc. So as the point P moves on the circle, theta will change and coordinates will change, but at every instant it lies on the same circle. So this equation is said to be the equation of circle in the parametric form. So this is called parametric equation of the circle. Parametric equation of circle, and theta is a parameter, varying angle. Parameter means something which varies, and it's a constant angle, which is parameter. The constant and the value is a number, but it keeps changing. And the angle theta should always lie between 0 to 2 pi. As the point moves on the circle, theta moves from 0 to 2 pi. This is called parametric equation, and the point P can be represented as r cos theta, r sin theta. So whenever you want to represent any point on the circle, you can assume like this, and these are called parametric coordinates. So we call them as parametric coordinates. So any point on the circle can always be represented in parametric coordinates. And usually most of the locus problems are done by assuming parametric coordinates. This is the first case where the center is origin. We can extend it to the other cases where center is hk and minus g minus f also. So for that, what we can do is, if the center is hk and the radius of the circle is r, so what is the Cartesian form of circle? X minus h whole square plus y minus k whole square equal to r square is a Cartesian equation. So this is the Cartesian form. And the corresponding parametric form, if you are writing, you just write down the same equation. What did I write earlier? X equal to r cos theta, but x will be changed as x minus h here. And instead of y, you write y minus k equal to r sin theta. So we need not derive again. In the previous equation, in the circle, x and y got changed as x minus h and y minus k. Here also changed as x minus h and y minus k. So we'll therefore get x equal to h plus r cos theta and y equal to k plus r sin theta. So this is the parametric equation of the circle, which is given in the standard form, whose center is hk and radius is r. Whose center is hk and radius is r. And here also theta lies between 0 to 2 pi. And in case if the circle is changed and the center is given as minus g minus f, and radius r is root of g square plus f square minus c. For this type of circle, what is the Cartesian equation basically? The Cartesian equation is x square plus y square plus 2gx plus 2f5 plus c equal to 0. So this is going to be the Cartesian equation of circle. And what would be the parametric equation? X equal to just the same thing, but center hk is minus g minus f. So minus g plus r cos theta. R you can write with the formula which I gave here. You can find and substitute here. And y will be minus f plus r sin theta. So this is the parametric equation of circle in the other forms. And every form theta lies between 0 to 2 pi. Form. So these are all the general forms that we have. Apart from this, there are some extra results which are given in problems, but you can also generalize them. So this is circle through 3 non-collinear points. Circle through 3 non-collinear points. And basically it's a circumcircle of triangle, because 3 non-collinear points usually form a triangle. So we are going to find the equation of circle circumscribing a triangle when three vertices are given. So if I have a circle circumscribing a triangle, so ABC is a triangle. This circle passes through all the three vertices, and these points are non-collinear points. What is the circle called? Circumcircle. So we'll see how to find out equation of this circle when you are given the vertices ABC, x1, y1, x2, y2, x3, y3. Some coordinates will be specified. How to find its equation. So can anyone tell me the method for this? So usually the center of the circle is nothing but circumcenter, because the point of concurrence of perpendicular bisectors of sides is circumcenter, and that will be the center of the circle. So basically, if you draw perpendicular bisector of this side, perpendicular bisector of this side, and perpendicular bisector of the third side also, the point where they meet is actually called circumcenter, and this circumcenter is usually equidistant from all the three vertices. It is equidistant from three vertices. That is only the radius of the circle, and S is the center of circle. So this circumcircle will have center is circumcenter, and the radius of the circle is nothing but called circumradius. This distance SA, SB, SC all are equal, and that will be equal to capital R. This is called circumradius, radius of circumcircle. And as I told you earlier, to find any circle, you need center and radius. If you can find the circumcenter coordinates and you can find out the radius, you will be able to find the circle. So to find circumcenter, what do? You can assume some coordinates for center as HK. Then you apply distance formula SA equal to SB, SB equal to SC. You get two equations, solve for the circumcenter. And if you quickly want to do, I have a formula for circumcenter directly for finding perpendicular bisector. So if, for example, there is a line joining 2 points, x1, y1, x2, y2, to write the perpendicular bisector, the formula is 2x into difference in x coordinates plus 2y into difference in y coordinates equal to sum of the squares of first coordinate minus sum of the squares of second coordinate. So this is a formula to find out perpendicular bisector of AB. Okay, this is formula for perpendicular bisector. Formula for perpendicular bisector. So what you can do with this formula of perpendicular bisector, you can find out any two bisectors. So you apply that for BC, you get this bisector. Apply for AC, you get this bisector. Solving them will give circumcenter. So you can just say solve. First, you can say find any two perpendicular bisectors and solve. Find any two perpendicular bisectors, and solve to get circumcenter. And if you don't want to use this formula, what are we going to do? If you're equating SA with SB and SB with SC, you get two conditions. Square, like SA you'll find with distance formula, SB with distance formula, SC with distance formula. And equating any two and squaring will give you two equations and you have to solve them. So whatever equations you get there, I gave a ready-made result, you can say. This formula is a ready-made result for finding that equation. And once you get that, you can find radius R by finding the distance from circumcenter to vertex A, which is already given, or SB or SC. So once you get this, what is the circle? So we can just write the required circle is x minus h whole square plus y minus k whole square equal to R square. Capital R square I'll mention. So this is how you find the circle. This is one method. You have two other methods for the same problem, but this is the first method. So we have a second method for this. So the second method is first you assume the circle directly. Let the circle be, because any equation will always reduce to this format. You can say let the circle be x square plus y square plus 2gx plus 2fy plus c equal to 0. Assume that this is the equation of the circle first. Call it as capital 1. Now, this equation 1 is the circle equation which passes through three vertices A, B, C. So this passes through A, B, C. So if it passes through A, x1, y1, B, x2, y2, C, x3, y3, what can you conclude if it passes through the three vertices? If this passes through the three vertices, every point should satisfy the circle. That means for xy, I can substitute any of these three coordinates. So when I substitute the first coordinate, you'll get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. Call it as equation 1, substituting the first point in circle. When you substitute the second point in the circle, for xy, you replace x2, y2, you will get x2 square plus y2 square plus 2gx2 plus 2fy2 plus c equal to 0. Likewise, you substitute the third point in the circle. For xy, you substitute x3, y3, you will get x3 square plus y3 square plus 2gx3 plus 2fy3 plus c equal to 0. So you got three equations. And usually to find the circle, you need three values g of c. If you know g of c, you know the circle already. So how to find g of c from here? Because x1, y1, x2, y2, x3, y3 are all numbers which are given. The unknowns in this sequence are only g of c. So what are the unknowns? G of c are unknowns here. How do you find them?
Three equations, three variables.
Yeah. So actually, if you subtract 1 and 2, c will get eliminated. 2 and 3, c will get eliminated. Then you will get only two equations. So you do first minus second, then second minus third. So this will gives an equation in G and F. It eliminates C. And this will also give another equation in G and F. This also eliminates C. Then you can just solve and find G and F. Solve and find G value and F value. And put these values again. Put G and F in any one of the equations, 1 or 2 or 3. In 1 or 2 or 3. In 1 or 2 or 3 to get C. And once you know these three values, what is the required circle? So the required circle is x square plus y square plus 2gx plus 2fy plus c equal to 0 for above values of c. For above values of c. So then we have a third method. And here we use the concept of family of circles. So usually if you have a circle, S, in short form, it can be any circle, you can call it by S. Like for example, even if there is a circle x square plus y square plus 2gx plus 2fy plus some c equal to 0. In short form, you can call it as S equal to 0, where S represents all this. For any type of circle, you can use this representation, even for the standard form. So call it as S. Then whenever I want to refer to circle in short form, I can just say S equal to 0. And if a circle is intersected by a line, L equal to 0 is a line, where if both are intersecting in A and B, through AB, how many circles you can draw passing through AB? So through AB, you can draw how many circles?
Infinite.
Infinite. So through two given points, you can actually draw infinite number of circles. So you can keep on drawing anything. So all these circles, the general form is S plus lambda L equal to 0, where lambda is a parameter. Where lambda is a parameter. So this is called as family of circles. And this family of circles passes through the intersection of S and L, which is A and B. Family of circles through A and B. And what are A and B? The intersection points of a given circle and a given line. So whenever a circle and line intersect, through their intersection point, you can draw infinite number of circles. Infinite number of circles. Yeah. So now if I want to find the circle through ABC, what I'll do? First, you consider a circle having any two of the points as the diameter. Like out of the 3 points, take any 2 points as the diameter of a circle, find the circle. So if there is a circle with ends of diameter as x1, y1 and x2, y2, how do you write this circle? X minus x1 into x minus x2 plus y minus y1 into y minus y2 equals 0. Yes, you are right. So this is a circle with AB as diameter. First write this circle, and this is our S equal to 0. And then you write down the line L, which is this line AB. So if you have to find the equation of line AB, what you can do is you take a random point xy, and the condition for collinearity will give the locus of P. That will be the equation of line. 2-point form only, I'm writing in a different way. Determinant of xy1, x1, y1, 1, x2, y2, 1. This is a condition for collinearity, but when you write this condition, you are actually writing the locus of xy, which is a point on that. So this will represent the line equation. Okay. So I'll just erase it. So that will represent the line equation. So whenever you want to write the line AB, you can use this. Then any circle through AB, what do you write? S plus lambda L equal to 0 is any circle through AB. So when I say this any circle through AB, how many values lambda will have? Infinite. But among those values, for example, if I draw a circle through AB, for some value of lambda, it will give one of the circles. Like there are many, infinitely many. Among that, I have shown one circle passing through AB. So if it also passes through C, how many such circles will be there among that? Through AB, there are infinite. But if among those circles, if it has to pass through C, there is only one unique circle. There is only one unique circle. So what you do? Substitute C in this. You substitute C in S plus lambda L equal to 0 equation and find lambda. So lambda was the only unknown, and once you get the value of lambda, for this particular value of lambda substituted, you will get one of those circles which also passes through C. That is the required circle. Okay. Then find S plus lambda L equal to 0 with this lambda value. That is only the required circle. So this is the third method with family of circles concept.